Hello everybody. Today in this video we are going to be looking at the Pygame boilerplate code, and I'm going to be explaining it to you. So let's get into it. So I've got VS Code opened up over here, and the first thing that we see in the code are the imports. So we have imported two things over here. We have imported Pygame, obviously, and we have also imported the exit function from the sys library. Now this exit function is to basically say to Python that, okay Python, it's time to stop, and Python stops basically. So in Pygame, let's say when you run your Pygame code, you have this window, and when you press this red cross button, you want to say to Python, okay, when the user presses that button, you want to stop. So there we go, it stops. And over here we call that exit function, and we'll talk about that when we are looking at that part of the code. So now let's look at what's after the import. So we have got the pygame.init function. We are calling the pygame.init function. This basically initializes all Pygame modules. Next is pygame.display.setCaption, and over here we have set it to technopy. So let me show you what it basically does. So when you have a window, it sets the title of the window, right? So over here you can see technopy. We can change that to, let's just say, window title. There we go. Oops, I forgot the ending quote, and we've got the title, window title, changed to the text window title. So that's simple. Now let's move on to a few variables that we have created. The first is the frame rate variable. We'll be using it later in the code. You can see it's being referenced over here. And then we have got this clock variable. We have initialized a pygame.time.clock class over here, so we've got a clock object in there. And next we have a surface variable. So a surface is like a piece of paper. So a surface is where you do all the changes, like you create a box maybe, or maybe you create an ellipse, you move it, etc, etc. So you do everything on the surface. So the next part of the code is the screen. So the screen is basically a surface. So what we are basically doing over here is saying pygame.display.setMode, and we are creating a surface of this size, 960 by 540 pixel. And by the way, if you noticed, we created a surface of size 320 by 180 pixels over here with the variable name of surface. And you might be, so first let's just talk about the screen right here. So the screen is basically, what we are saying is Pygame, this is the variable that we are going to change. We are making all the changes in this variable. So this is the screen variable, and this is a surface. We are going to be making all the changes to the surface. So when I tell you to update the screen, so what you have to do is look at all the changes that I make in this variable, in the screen variable, and then show it to the user. So Pygame says, okay, so this is going to be our screen. This is where you make all the changes, you show to the user. Now you might be wondering, why do we have two surfaces in this code, right? So we have got this surface and the screen. Now the reason why we have two surfaces is because I like a nice scaled up look, right? So basically what you have is this screen. This is literal pixel size, right? So if you want to create a box of 5 by 5 pixels, it'll look really small, and it's literally a pixel in your screen, right? So that is what a 5 by 5 pixel box means, right? But what we want over here is we want it to look nice and big, and I prefer a nice and big scaled look, and that's why I have created two surfaces. So we will make all the changes in this surface, and we will scale it up, and we will paste it on the screen so that it is shown to the user. So let's move on. So the next part of the code is this while loop. So any Pygame code will have this main while loop. So in this while loop, you make changes to the screen, right? So you make changes to the surface, and then what you do is you show all the changes to the user. So this loop runs about 60 times a second maybe. So you might be asking, well, how do you know that it runs 60 times a second? It can run any number of times a second. It depends on how much time it takes for one loop to execute. So you were right at that point. So I could have just a little bit of code in this loop or a lot of code in this loop. So it depends on how much time it takes for all of that code to execute to calculate the number of times this loop will execute in a second. And that's the reason we have this clock.text statement over here. So it basically, what it does is it regulates the number of times this loop loops during a second. So you don't want it looping like 1,000 times a second, because we don't want to post 1,000 frames a second. So what I'm saying here is, let's say we have a box and we are moving it by 1 pixel in each loop, right? So if you have 60 loops in a second, it'll look as if the box is moving fluidly. It doesn't look as if the box just disappeared from one place and appeared 60 pixels in another place. Yeah. So we want it to have a nice and fluid motion. We want everything to look like a video, right? So basically what a video is, it's just a bunch of images shown really fast to your eyes so that it looks as if it is moving, something is moving fluidly, right? So over here in Pygame, what we do is in each loop we make a change, and when the loop runs more than like 24 times a second, for our eyes interpret it as a moving object. So that's how videos actually work, right? So in Pygame you have got the statement clock.tick, right? So let's say in each loop you move a box by 1 pixel, right? So if you have 1,000 frames, you'll be moving that box 1,000 pixels in just 1 second. So you don't want that to happen. You just want to regulate the number of times this loop runs. So you just call this clock.tick function, which is a part of Pygame library, and it says, okay, we just want it to run a few times, right? So like 60 times a second or 100 or 120 times a second. So it depends on the frame rate, right? So we pass it the variable of frame rate, and this variable is equal to 60. So what it does, it regulates the amount of times this code runs, right? So it regulates the number of loops. So that's what this while true statement is for, and this clock.tick statement is for, right? So let's move on. So the next thing that we do is we fill the surface. So the surface is where we are making all the changes, right? So the surface.fill, what it does is it sets the background for the surface. So I have set the background to a tuple. The tuple contains R, G, and B values, and I have set it to 0, 0, and 0, which is basically black color. So it fills with a black color, so you can see that over here. So this happens every loop. So every time this loop runs, it fills it with a black color, and it does the next change. So this is the first part of the loop. Next, what we do is we look through a list of events. So Pygame records a list of events of things that are happening, maybe key presses. Let's say the user moved their mouse, that is an event. The user pressed some key, maybe the up arrow or maybe the down arrow, that is an event. So another thing that registers as an event is when you click on the top red, the red cross in the top right corner of a window, right? So that is registered as a pygame.quit event. So what happens is when we are looking through this list of events, we say, is there any event of the type pygame.quit? If there is an event of this type, we would say, okay, that means the user has pressed the the cross in the top right corner of the window. That means we need to stop this program. So we say exit. So we say, Python, it's time to stop. Okay, the next thing that we do is screen.blit and etc that is inside it. So you remember the part where I said we have two surfaces. One is the surface where you are making the changes, the smaller one, and the screen, which is being shown to the user, right? So what we are doing over here is we're saying, okay, we have made all the needed changes that we need to make to the smaller surface. Now we need to scale it up so that it looks nice and large, and we need to paste it on the main screen, right? So we say pygame.transform.scale. This scales our smaller surface to the pixel size that we need. So this is the larger pixel sizes. This is the size of the larger window, the larger surface. And then we say, so we say this is what we want to transform, scale it up to 960 by 548 pixels. After that, what we do is we say screen.blit, and we say, okay, screen.blit, what it does is this blit function takes in an image and it says, okay, we need to paste this image somewhere. So what we are doing is we are saying scale up whatever's in this surface and provide it as an image. So we are saying pygame.transform.scale. What it does, it basically takes in the smaller surface, it scales it up, it provides this as an image, and we are saying paste it at this coordinate, paste it at 0, 0. That means top left corner of the window. So it pastes it from the top left corner of the window, and it pastes everything from our smaller surface onto the bigger screen. Now what next? So what happens is you make all the changes onto the screen, right? So we have made a change onto the screen. Now we want to show this change to the user. So what Pygame expects you to do is make all the changes that you need to make during the loop. And then at the end of the loop, you say update the screen. So you'd say, I have made a lot of changes. You just need to show that change to the user now. So what this pygame.display.update does is it knows that this screen is the variable where we make all the changes. So it says, okay, so this is the variable where all the changes have been made. I need to show that to the user, and it shows it to the user. Next is clock.tick. We already talked about this. Now one more thing that I want to mention about this is, let's say your code is really big and it is taking more than some specific amount of time to execute. So it is less than 60 frames per second, right? So at that point, clock.tick cannot do anything. It knows that it is below 60 frames per second, so it does nothing. But when the code is running really fast, above 60 frames per second, at that point, it will regulate it so that it posts only 60 frames a second. So that is how this code works. And there we go. Congratulations, you have understood the basic structure of any Pygame code, and I hope you enjoyed the process, and we'll meet in the next video. Thank you and have a nice day ahead.